All right, guys, so we are going to go ahead and finish up 8.9. I only have like two problems that I want to show you here. These are just some more difficult um, Pythagorean identity proofs. So we'll go ahead and call this 8.9 part 2 of Pythagorean identity proofs. Okay, so just a couple. We did a lot of the basic ones in our first video. We had like 6 examples where we used a lot of different strategies. These are just problems that are on the more difficult end. So I'll just say more difficult. Problems that are on the more difficult end of Pythagorean identity proofs today. So I only have 2 of them that I want to show you. So it'll be much shorter than the first video that we had. And then I'll have some more practice for you guys to try for your assignment for these couple days. So here is our first example. Once again, the directions will be to prove this. In other words, take what you see on the left side and transform it using identities into what you see on the right side of the equation. All right, so for our first one today, let's try cotangent of theta times cosine of theta divided by 1 plus sine of theta equals cosecant of theta, minus 1, okay? All right, so first thing that I would like to do here, remember one of our strategies, anytime you see a cotangent, go ahead and change it into something that involves only sine and cosine. So in this case, we'll write it as cosine of theta over sine of theta times cosine of theta divided by 1 plus sine of theta. 1 plus sine of theta, okay? So I change that cotangent of theta, do a little bit of multiplication here. Cosine of theta times cosine of theta gives me cosine squared of theta, okay, divided by sine of theta. And that's all divided by 1 plus sine of theta, okay? I'm going to do a couple things in one step here. First of all, notice that on the right side of the equation, all we see is a cosecant of theta. Cosecant, when you see this, you should be thinking sine of theta. Okay, think about sine of theta. We know that cosecant, and sorry, that was a terrible penmanship, whatever that word is, right there. So think sine of theta. So over here, we see a cosine squared of theta, but I don't want cosine. I would like this to be sine. And as we mentioned in our first video, anytime that you see a cosine squared, if you would like to, you can replace that with a sine squared using the Pythagorean identity. So you can replace a cosine squared of theta with 1 minus sine squared of theta, okay? So I'm going to go ahead and rewrite this cosine squared of theta as 1 minus sine squared of theta divided by sine of theta, okay? And then I'd like to make a note here. This looks like a giant mess, okay? Let's see if I can actually give myself a little bit more space here so it's not all smashed together, okay? So I replaced the cosine squared of theta, but what I'm doing right here is I'm dividing 2 fractions. And what we've learned this year is that when you divide 2 fractions, that's the same as multiplying by the reciprocal. So just to help myself out here and make this look a little easier on the eyes, I'm going to write this as 1 over sine squared of theta, 1 minus sine squared of theta divided by sine times 1 over 1 plus sine of theta, okay? Because I'm copying the first fraction and I'm multiplying by the reciprocal of the second fraction, okay? And actually from here, I'm almost done with the problem. Here I see a 1 minus sine squared of theta. Here I see a 1 plus sine of theta. If you remember, one of our strategies is to factor something as a difference of perfect squares, okay? And in fact, that's going to help us here. If I factor 1 minus sine squared of theta as 1 plus sine of theta, times 1 minus sine of theta. I'll keep everything else the same for now. This is helpful because now I can cancel out this 1 plus sine of theta here and this 1 plus sine of theta here, okay? So if I'm kind of condensing all this down now I've got 1 minus sine of theta times 1, which just stays the same. And on the bottom here, I have a sine of theta times 1, which just gives me a sine of theta, okay? Now, this brings us to another strategy, which we've mentioned this in the last one as well. What I have right here is I just have one term, one big fraction. But on the other side of the equation up here, I have two terms. Well, how am I going to take one term and turn it into two terms? What I should do is keep in mind this statement right here. Here I have one fraction, but this is the same thing as 3/4 plus 1/4. Okay, I can take this fraction right here and I can split it just like I'm doing with this 3 plus 1 over 4 right here. So I'm going to go ahead and I'm going to take this fraction and rewrite it as 1 over sine of theta minus sine of theta divided by sine of theta. Okay, and then from here I can finish the problem because 1 over sine of theta is the same thing as cosecant of theta. And sine divided by sine is the same thing as 1. And that is exactly what I wanted here, was I wanted cosecant of theta minus 1 when I'm finished, okay? So once again, if we're reviewing strategy, I changed cotangent into cosine over sine, okay? And then I multiplied here, this became cosine squared of theta, and I noticed there's no cosines over here, so I'm gonna replace this cosine squared of theta with 1 minus sine squared of theta. Okay. I'm also going to make this a little easier on the eyes by writing this as multiplication instead of division. When I divide by a fraction, that's the same as multiplying by its reciprocal. Okay. I went ahead and factored this 1 minus sine squared of theta as a difference of perfect squares. What that allowed me to do is I was now able to cancel out this 1 plus sine of theta here and this 1 plus sine of theta here. Okay. Now, from this step, what I was now able to do is take this fraction and split it into two separate fractions so that I could get it to look like the two terms on the other side of the equation. Okay, 1 over sine of theta is the same thing as cosecant of theta. Sine divided by sine, I can divide those out, and I'm only left with 1. Okay, so this is a little bit trickier of a problem because it has quite a few different strategies in it. It's still a problem that we're capable of doing, but it takes a little bit more thinking on our end. Okay. All right, one more here, and then we will be done with this video. Okay, and this is definitely one of the most difficult ones that we've seen thus far. See if you can follow along, and you'll have a chance to try some of this difficulty level on the assignment for these couple days. So here's what we've got. Tangent of x, like minus secant of x, plus cosine of x, all divided by 1 minus sine of x, is all equal to tangent of x, okay? So let's do a little bit of legwork here at the beginning. Let's change this tangent of x into sine of x over cosine of x. And another thing that I'm going to do is I'm going to change the secant of x into 1 over cosine of x, okay? Everything else I'm going to go ahead and keep the same for right now. Okay, and take a look up here on the top. What we've got is we've got a bunch of different fractions, okay? As we mentioned in that first video, anytime you have a bunch of fractions, something that you're going to want to do is get a common denominator between all of it, okay? I have a cosine, and a 1. The common denominator there is going to be cosine of x, and I don't want to forget about what's on the bottom here, so I'm going to go ahead and write it again. So on the bottom, I got a 1 minus sine of x, but let's worry about what would happen if I found a common denominator between all of this, okay? If I'm thinking about each term individually, this already had a cosine of x, so I'm not going to change it at all. This one already had a cosine of x, so I'm not going to change it at all. This one had a 1. I multiplied in a cosine, which means I need to multiply cosine on top. So what this is now going to become is plus cosine squared of x, because I got to multiply cosine times cosine. Okay? All right. From here, this is where this problem starts to get a little bit tricky. Okay? You might need to play around with some different things, but as I'm looking at this problem, what I'm noticing here is that on the right side of the equation, I have a tangent of x, which means the only thing that I'm going to want to have on the top is a sine of x, okay? Because tangent is the same thing as sine of x over cosine of x, okay? So what I'm thinking here is that I have a cosine squared of x here. That's on the very top of this entire fraction. I'm not going to want a cosine of x on the top of this fraction when I'm done. I'm only going to want a sine of x. So what I'm going to do here is I'm going to use the Pythagorean identity to change this cosine squared of x into, I'm going to keep everything else the same here. Okay, everything else is going to stay the same. But I'm going to change this cosine squared of x into a 1 minus sine squared of x. Okay. I'm going to put parentheses around it so I make sure I know I'm taking that whole term and replacing it with 1 minus sine squared of x. Okay. From here, I can start to do a little bit of simplifying. Notice that what I have here is a -1 and a +1. Those are going to cancel each other out. Okay, and I'll be left with sine of x minus sine squared of x divided by cosine of x. And I could have done this a couple steps earlier. Remember, when I am dividing two fractions here, as I mentioned in the last problem, that's the same as multiplying by the reciprocal. So I'm going to go ahead and rewrite this as times 1 over 1 minus sine of x. Okay. Now from here you might feel a little bit stuck, but notice on this fraction, the numerator, both of these terms have a sine of x. Okay. So it might help me to take out a sine of x here and see what I'm working with when I'm done. Okay, so I'm going to try that here. Okay, let's get everything written down and then we can evaluate and analyze. So we've got sine of x times 1 minus sine of x over cosine of x. This is what's left over when I factor out that sine of x, times 1 over 1 minus sine of x. Okay, from here, this was useful for us because by factoring, I can now see that I can cancel out that 1 minus sine of x on top and bottom, leaving me with only a sine of x over cosine of x, which, as we mentioned on the right side of the equation, I'm trying to get tangent of x, which is exactly sine of x over cosine of x. So when I'm finished, I get that tangent of x is equal to tangent of x. And just like I expected, I am now finished with my problem. Okay, so for thinking strategy on this one, I changed these tangent of x's, or I changed this tangent of x. I also changed this secant of x, found a common denominator. Okay, use the Pythagorean identity to replace that cosine squared of x. Combine the like terms, these ones canceled out. Okay, that left me with the sine of x minus sine squared of x. I went ahead and factored out the GCF here, the sine of x, and what I was left with was a 1 minus sine of x, which allowed me to cancel out with this 1 minus sine of x here on the bottom. Okay, this left me with only a sine of x over cosine of x, which is exactly the same thing as tangent, which is what I was trying to show that this problem was equal to in the first place. Okay, so there's a couple of more difficult problems on the more difficult side of trigonometric proofs. I'll put an assignment up that has some easy problems on the front. It's got a little bit harder problems on the back, and you can practice some of these and see where you're at. We'll have another quiz coming up soon. I'll give you some more details on that when I have them. Okay, I will see you guys later. Bye.